today, before we start, I want to just have an information for you that this session is going to be recorded and it's going to be uploaded to YouTube. So please turn your or hand your microphone and the video in the light of this fact. If you have any questions, I'm happy to answer that after my presentation. You can have questions on the chat or either already after my presentation. So today I'm going to talk about the acquired equivalence test and its clinical relevance. But before we start that, I want to just introduce myself a bit. So I'm a medical doctor and I graduated in the University of Szeged in Hungary. If you ever wonder where this mighty University of Szeged is located, so you might familiar with Hungary, which is located in the Central Europe. I think Norway is in the background. It cannot really seen from here. And Szeged is basically the southern part of Hungary. And my institute was located actually in the main square of Szeged, so it was pretty cool to work here. After my graduation, I did my PhD in neuroscience in the same University of Szeged, but I also did a scholarship in Aachen in Germany, studying the fMRI basics, and then a short scholarship in Leuven in Belgium. After my PhD defense, I started to work as a postdoc here in München at the Helgeland Hospital in the neuropsychological department. And I started to work in the framework of the adult ADHD II project. I will also have some presentation of this project where we are at the end of my presentation. So thank you again to invite me to have this lecture. I hope you don't find this as a mistake. But if you do, it's okay. People often make mistakes. In fact, it's a human nature to watch other making mistakes, and today's big entertainment of us that we are watching others making mistakes, and hopefully we can learn them. But it's not restricted to just human nature. It's also for other species as well. And you might think that this novel entertainment is some new stuff of the modern era, but it's not. In fact, it was James Thorndike in the early 90s who made an experiment of cats, and what he basically done is he put his cat in a cage, and there was a leverage inside the cage that opened the door, and he just made some experiments how the cat is actually learning how to open the cage itself. So based on this experiment and several other experiments, of course, Thorndike made the foundation of how we are learning, and he came up with the idea of this trial and error learning. So trial and error learning means that we are trying something. Sometimes we are failing, sometimes we have good feedback. But based on this feedback, we are building up some memories, and based on these experiences, we build up memories, and we can generalize this memory to other situations as well. Of course, nowadays we are doing this in a modern, sophisticated way in terms of the research. And so in the late 90s, Catherine Myers and her colleagues just came up with a new cognitive test, so-called the acquired equivalence test. And the basic function is or the basic task is to select which of the two presented colored fish associated with the presented face here. So first, you of course don't know, you have to guess, but you get the feedback, and based on this feedback, you will optimize your cognitive performance. So that's the basic structure, and but the test itself has three main phases: the acquisition phase, the retrieval phase, and the generalization phase. So during the acquisition phase, you learn by trial and error learning, so by feedback, 6 possible fish pairs out of the possible 8 pairs. Now that it's done, you ended up in the retrieval phase, where you don't get any feedback, but you have to remember those associations that you already learned. And in the generalization phase, you can generalize the basic rule that you learned during the acquisition phase to a new situation. So for this particular example, you learned that the face of the woman and the girl are so-called equivalent in terms of the colored fish that they are associated with. So if you learn that the woman is associated with the redfish, then you can guess out easily that the girl is also associated with the redfish. And the same goes, of course, with the man and the boy. Okay, so this is the basic structure of the acquired equivalence test. And now I want to talk about some neuroanatomical considerations that have some background of this test. So one specific aspect of this task that it was done in Alzheimer's disease patients. And what they found that with this test, that a patient with Alzheimer's disorder have serious troubles in generalizing new, so transfer the already learned rules, but other functions were kind of okay. But this was the main difference between healthy controls and Alzheimer's patients. And from earlier studies, we know that Alzheimer's disorder is mainly associated with decreased volume in the hippocampus and in the mediotemporal lobe. Now, if you are not familiar where this structure is located in the brain, it's okay. You just have to remember that hippocampus and mediotemporal lobe is mainly associated with the second part of the task. There was another series of studies that performed with these tasks, and they performed in disorders in which the basal ganglia is affected. Basal ganglia is also a structure that's located somewhere here in the brain, and it contains several nuclei. For example, the globus pallidus, thalamus. If it always sounds not so familiar for you, it's again okay. You just have to remember that basal ganglia is a structure somewhere in the brain. What they found that this basal ganglia system is very much crucial in the first phase of the acquired equivalence test. So in the trial and error learning. They found it in Parkinson disorder patients. They found it in cocaine users, and they also find it in a patient with obsessive compulsive disorder. So updating our figure with the structure of the acquired equivalence test, we can say that the earlier initial phase is dependent on the basal ganglia nigrostriatal dopaminergic system, while the second part is mostly dependent on the hippocampal mediotemporal lobe system. So take-home message from now on is that how we learn from our mistakes is dependent on the basal ganglia itself, and it's disrupted in Parkinson disorder, substance abuse disorder, OCD, Tourette syndrome, and so on, while maintaining our memory and how we generalize these earlier experiences is mainly dependent on the hippocampus or the mediotemporal lobe. I covered a lot of disorders, symptoms here, But I want to focus now into migraine, because that was the main study that we done in Hungary, in Szeged. So migraine is considered as a primary headache disorder that lasts for 4 to 72 hours, and usually it's a unilateral location, means that it's located to only one side of your head. Often it has a pulsating sensation. It can have a moderate or severe pain intensity, and it's often accompanied by nausea or vomiting, and patients often have a slight disturbance of light or sound. So why we were interested in this disorder or syndrome is that some studies denoted volume reduction in several brain areas, including the basal ganglia. And so we were curious how how the cognitive profile in migraine would be affected, or is it affected at all? So our aims was to investigate how the migraine disturbs the cognitive functions, uh, also in both in adulthood and in early childhood. And for that we use the acquired equivalence test that I just presented you moments ago. So in total we have 27 participants, both in adult and in childhood, and both from healthy controls and patients. And our findings denoted were published in Cephalalgia, and I'm happy to announce that our figure just made it to the front page for this current volume. So we are very happy about that. So basically what we found that in the adult group, we found significant differences in the cognitive performance. So basically, migraineurs performed worse compared to healthy control groups. In the y-axis, you can see the error ratio. So the higher this error ratio, it means that they were performed. So yeah, we found it in the adult group, but investigating the pediatric group, so the child group, we haven't found any difference in the cognitive performance. So that it was a really interesting finding also, but of course this has some limitation, as all study has, and I would just want to discuss these results with you. So of course the limitations are that we had a simple sample size, and of course the test was not fully developed, and I will get into a bit later. But our results suggested that the decreased performance in the test, it's not a inherited damage that comes with the migraine, but rather a damage that comes or develops further with the disorder. At least we are seeing this from our results. So that could raise the issue that is migraine a neurodegenerative disorder, because earlier it was considered not to, but this new findings could raise this issue. Of course, it might be not so selective damage that causes the migraine. It could damage also other areas, rather, not just the basal ganglia system, and of course many other tests would be required to shed light on what exact damages are in migraine. Of course, follow-up study is needed, because there was not a follow-up study, but rather just a comparison between different age groups. But I still think it is a curious findings, and within all these limitations. Okay, so what is the next step with this task, or how we get through? First, what we want to do, and we have done, is to improve the test itself. And of course, we want to use it other clinical groups. I will talk first how we can improve this task. We can do it in three ways: omitting preconceptions, investigating the working memory instead of the trial and error learning, and include somehow the spatial attention. So how our attention is focused during the task. Okay, so let's go point by point. So how do we omit preconception, or what are preconceptions? So color face associations are often biased and highly affected by these social preconceptions, and mainly for that's good states for the children, but also for adults. What I'm trying to say is that if a participant would see a face with a boy with two different, with the colored blue and the color red, participants often choose the color blue because it's kind of mannish or boyish or more boyish colored rather than the red one. Of course, it doesn't. It's not specific to everyone, and not. But we want to get rid of this social preconception, and that's how we ended up to have a segmented circle and a neutral shape that you can associate with. So that is what improving that we have done. The other part that we can improve is to investigate the working memory instead of the trial and error learning. And before I get into how we done it, I have to introduce these terms specifically. So I guess you are familiar with the trial and error learning. I already stated it in the early part of my presentation. So this is Jim Trondijk, and assuming this is some kind of a revelation of his cat. And but you are not familiar with the term working memory. So working memory is the is basically holding information in your mind while you are manipulating it. And why you manipulating it is very important, because if you are not manipulating it, that is just short-term memory. Let me give you an example. So if I say, repeat after me the numbers 4265, it's very very easy to do so. 4265. But if I ask you to do it in backwards, so 5624, it would be much more harder, and that's working memory itself, or more like working memory. And working memory load is actually the number of items that you are currently holding in your mind while you are manipulating it. And in humans, the maximum working memory load, it's about 5 to 7. Okay, so of course, both trial and error learning and working memory is present in the acquired equivalence test. Let's see how. So during the test, you are learning the pairs through trial and error, meaning that you randomly pick a shape or a colored fish, you get a feedback, and then you optimize your performance based on this feedback. Working memory is also present in the acquired equivalence test, because you need to remember more and more pairs during the test. So first you learn just one pair, then two, then three, and so on, and you need to update these memories constantly. So how do we get rid of this learning, trial and error learning? Well, we cannot completely get rid of them, but if we tell the rule before the test, so we actually tell what feature is to focus on first, and what will be the rule, then it will be much less trial and error learning. The third thing, how we can improve our test is to include somehow spatial attention, because sometimes, often, these focusing on our attention is very could bias the actual performance of the task. So let's say you are more likely to focus what's in your right visual hemisphere or what's located in the left side. It could cause some serious violations of the performance. So our solution was to manipulate the focusing point of the task. We did it two ways. So to change the number of distractors. Distractors mean that the items that actually pop up to in the visual field that actually not important in the task but can drift away your attention. And we also changed, manipulated the left or the right visual field dominance. So that's how we ended up for different segmented circles. You can see that the number of distractors are dependent because the number of segments is increased, or you can manipulate the visual field itself to the left or the right side. Okay, so putting all together, we ended up in the specific constellation in which we use segmented circles, and we use constellations in which you have to just learn 2 pairs and after that 4 pairs, with a help that we are foretelling the participants what feature is to look for. Okay, so I understand that first it might be hard to understand and you probably didn't fully understand all of it, which is totally okay. The main thing that you have to remember from this section is that we developed a new task, so-called the progressive equivalence task, that is based on the earlier associative learning task, but it includes more the working memory and the spatial attention. So we can actually investigate both the working memory and the level of spatial attention itself. Okay, so that's how we improved our task. Let's see what we can do with it. So how can we use in other clinical groups? And the first point, actually the 0 point, is always to have some normative data. You know, some data from healthy controls that we can compare other clinical groups to. So actually, we are currently planning to send out this developed test to healthy volunteers, and the idea is that because of the Corona time, we just like to reduce the amount of physical contact. So they do the test at home and they're at their home computer, and then we get the behavioral data back. Now, it's important to emphasize that this data is anonymous, of course, so there's no chance that we can track back the data, avoiding thus the GDPR and other ethical issues that could be raised here. Okay, after we are done this, our aim is to investigate this task in ADHD population, and is specifically interesting because in ADHD the working memory and attention is highly affected, and if you remember, this specific task could be very good to dissociate what cognitive domain is more affected in ADHD. So this test will be used as one of our experimental tasks in the research project. And in the next slide, I would just quickly summarize what this project is about. So this project ADHD II is founded by Hazenor, and we're doing it in Hegel and Sikahuset. We do it with the collaboration of many collaborators, namely in the University of Oslo, a hospital in Vestfold, with the group of ADHD Norge, also Tromsø University is a part of it, and we have a good collaborator located in University of Berkeley. So the main goal of this project is to investigate the so-called executive functions and the connected brainwaves in adult ADHD. So executive functions stands for these cognitive functions that are crucial to make like proper decisions. For example, working memory and also attention is one of them, but inhibition and cognitive inhibition is also part of that. So we're doing this project in a 3 level with the help of neurophysiological assessment, with clinical questionnaires, and with the help of EEG, so electroencephalogram, with 3 experimental tasks. EEG is good to electroencephalogram is a tool to just record our brain waves while you are doing specific tasks. So what we are doing is actually to put a cap on, and then we record the electrical waves that comes from the brain while the participant is actually doing the task. Okay, so we are doing this EEG recordings with 3 different tasks. One is the mind-wandering task, one is the stop signal task, and the other is the acquired equivalence task that I was just talking in this lecture. I'm not going to talk in the other 2 aspects of the tasks, but if you are in a position that you actually can have ADHD participants, or you want to involve more in this study, please do not hesitate to contact us, either my boss Venke Grane or me myself. I think this presentation will be available also in PDF format, so we are happy to have you in contact. Okay, so let's summarize what this presentation was about before you are going to have another coffee in this Friday morning. So apart from funny pictures, you learned what this acquired equivalence task actually is, and the basic structure of trial and error learning that is basal ganglia dependent. You also learned about migraine, and what we found in migraine, that no behavioral changes in childhood, but the decrement in behavioral performance in adulthood raises the question that is migraine a neurodegenerative disorder? I think it's at least an interesting point to make in Friday morning. The other thing that you learned today is that we modified this acquired equivalence test so we can focus more on the working memory and the spatial attention, and we can use this task in the project termed Adult ADHD II, and we would very like to have you involved. Yeah, I think that was all that I wanted to cover in my presentation. Thank you again, and I still hope that you don't find it as a mistake, and I'm happy to answer any questions you have.
Well, thank you, András, for a very nice presentation. Are there any questions for András? Or? Okay. I have one question. I mean,
Go ahead.
yeah, you talk about migraine, and it might be a neurodegenerative disorder, but if that's so, what kind of implications are there for a therapy for migraine? Your results. How can your results lead to another type of therapy?
Um, I don't think it's thank you for the question. It's a good question. I'm not sure. I'm not so sure how we can. Uh, Maybe we can include this new information as a part of the therapy itself, because you can also use the cognitive tests to actually track the migrainer's performance. So you don't need to um, perhaps you don't need to go to the hospital every time you want to get assessed for a migraine. But you can, for example, do some cognitive tasks, and then your physician would evaluate if you need another treatment for your migraine or not. Um, that's of course it's in a very earlier phase, and several studies are needed to develop in this slide. But I think it could be one solution.
Okay. Are there other questions to Andreas, or you can also type your questions in the field, in the chat field, if you don't want to participate in the video.
Yeah, and you can also send if you have any questions via email or after these presentations.
So you are a hitchhiker, Andreas.
Yeah, okay. Thank you for yes. This is from a Hitchhiker's Guide to the Galaxy. 42 is the answer for everything.
To bring your towel with you.
Yes.
Well, have a nice weekend, and thank you very much for an entertaining presentation.
Thank you very much, Gerard.
Thank you.
Have a nice one. Bye bye.
Bye bye.